problem 9. I don't think this is too hard. Who is this guy? Who is this guy?
Cartesian guy.
The Cartesian guy.
The Cartesian XY coordinate
There you go.
guy.
There you go. There you go.
Not Al-Kruski.
No. So his name, the very term Cartesian, has his name in it, or part of his name. That right there. His name is Descartes. So Cartesian system, that's Descartes. What do you suppose his nationality is?
French.
Yeah, you can tell that just from his name, right? He's French. We got that part. When did he live? And you can kind of tell that he's not from antiquity or anything. You can kind of tell from the way he's dressed. You know, the hairstyles and the facial hair and,
It's like late century.
1590. The 17th century.
Yeah, the early part of the 17th century.
So
The guy was a Renaissance guy.
So Al-Kruski came way before.
825
Yeah.
AD. Yeah, way before. And it took all that time before somebody realized there was a connection between geometry and algebra. What was his contribution? What his contribution was to the topics covered in this course? Well,
Everything about drives.
it's the connection between geometry. Yes, graphing. It's the connection between geometry and algebra. And you can see why that's such a huge step forward, is because you can begin to visualize things. And what mathematical idea bears his name? That's the Cartesian coordinates. Where would we be without that? So that's 9. 10. Okay, this is the locksmith problem. Dreaded word problems. A locksmith has an inventory of keys and locks totaling 100 items. So let's do keys plus locks equals 100. I'm going to use K and L. A key costs $1 and a lock costs $5. The total value is $320. So if I take the number of keys and multiply by 1 for $1, and the number of locks and multiply by 5, then his inventory is going to be $320. This is the total value problem. Remember, we talked about total value problems. The first equation of the total value problem is usually the sum of the number of items. And the second equation in the total value problem has to do with the value of each item totaling a total value. Okay, so what would you do to solve this? Go ahead. What would you do?
I did 100 minus x equals 1. Oh, you did k now. Okay. I had the keys represent x and the locks at
Oh, yeah, that's okay.
y. So I did 100 minus x equals 1. And then 1x plus 100 minus x times 5 equals 320.
Okay.
And I solved it.
I mean, yeah. What I would do, I wouldn't, for example, I would not use Cramer's rule for this. We talked about Cramer's rule and determinants and coefficient matrices and all of that stuff. I would just subtract the two equations. So I would take the first equation and subtract it from the second. That knocks out the number of keys, and I have 4 times the number of locks equals 220. So the number of locks is equal to 55. Fast enough for you? It's just that easy, right?
Wait, how did you score again? Sorry.
Okay, I decided I'm going to use elimination to eliminate K. So I'm going to subtract from the second equation the first equation.
Yeah.
So that removes K, 5L minus L is 4L, and 320 minus 100 is 220. Divide by 4, and I'm done. And so therefore the number of keys has got to be 45. Now why he has 55 locks and 45 keys, I don't know. He's not very good
So
locksmith.
simple. This seems so hard to me.
Does it seem hard at this point, right?
It's the wording that's,
Yeah.
Well, I think this is where algebra really shines over verbal descriptions. Once you get it into the symbolic form, everything just falls apart. The challenge tends to collapse into something very simple. So, but yes, this is the dreaded word problem. The hard part was getting to this. But once you get to this, then you have a choice of all these different methods to solve it. Well, that's all there is to the total value problem. Okay, any other questions on this? Okay, let's go to the next segment.